Hello everyone, welcome to another video on time, speed and distance by THiNC Institute of Design. My name is Jackson, so let's get it started. So in the first video of time, speed and distance, we were discussing about the basic formula, that is distance equals speed into time. And we did some other concepts also that, something connected to average speed. So let's see what else is there in time, speed and distance. So first of all, we are moving on to the concept of relative speed. So what is the concept of relative speed? So imagine you are moving in a train and you are moving at a speed of, let's say, 100 kilometers per hour. So you all might have traveled in it in trains and all. So imagine you are moving at a really high speed, 100 kilometers per hour. On a parallel track, there is another train moving in the opposite direction at a speed of, let's say, 120 kilometers per hour. So you're moving in one track at a speed of 100 and another train is crossing you in the opposite direction on a parallel track at a speed of 120. So you are moving at 100 and other train is crossing you at 120. So when you look at that train, do you feel like that train is moving at 120? Obviously not. You're already moving at 100, other train is crossing you at 120. So when you look at the other train, you feel like the train is moving really fast. So what you feel is the sum of the speeds, that is 100 plus 120, 220 is what you feel when you look at the other train. So relative speed is the sum of the speeds when two objects move in the opposite direction. So when two objects move in the opposite directions, relative speed is nothing but the sum of the speeds. So relative speed is the sum of the speeds when two objects move in the opposite direction. Now imagine you are moving at 100, another train is crossing you at 120 in the same direction. So you are moving at 100, other train is crossing you at 120 in the same direction. Now when you look at that train, what you feel, you are already moving at 100, other train is crossing you in the same direction, not opposite, same direction at 120. So when you look at the other train, what you feel is only the difference. So what is the difference of 120 and 100? It's 20, right? So when you look at the other train, you feel like the train is moving at 20 only. So relative speed is the difference of the speeds when two objects move in the same direction. So when two objects move in the same direction, relative speed is the difference of the speeds. Now, in what all situations we can make use of it? That is what we are going to look at. Okay, so let's see all these one by one. So the first situation where we make use of this formula is the case where we have to find the time taken by two objects to meet each other. Okay, so there is a direct formula. Let me just write down the formula first of all. That is time taken to meet each other. Time taken to meet each other is equal to distance when both objects started moving all divided by relative speed. So time taken to meet each other is equal to distance when both objects started moving all divided by relative speed. Okay, let's see how we can make use of this concept. Imagine there are two objects. One is moving from A to B, other is moving from B to A at a speed of 40 kilometers per hour and 60 kilometers per hour. And they both left at, the speeds are 40 and 60 kilometers per hour. They both left at 10 a.m. in the morning. And the distance between these 2 points, A and B, is, let's say, 60 kilometers. Okay, so I'll explain the question again. There are two objects at a distance of 60 kilometers. They both started traveling towards each other at 10 a.m. in the morning. One person is moving at 40, other person is moving at 60. So one person is moving from A to B, other person is moving from B to A, and they're moving at a speed of 40 and 60. So at what time will they meet each other is the question. So what is the formula saying? time taken to meet each other is equal to distance when both objects started moving divided by relative speed, right? So what is the time taken by these two objects to meet each other? That is distance when they started moving. So when they started moving at 10 a.m. they started, right? When they started moving, so time taken to meet is what we are going to find out. So time taken to meet is distance when they started moving. When they started at 10 a.m., distance between them was 60 kilometers. And what is the relative speed? Relative speed is the sum of the speeds. That is 40 plus 60, which is 100 kilometers per hour, right? Because relative speed is the sum of the speeds when two objects move in the opposite direction. So one is moving at 40, other person is moving at 60. So since they are moving in the opposite direction, relative speed is the sum of the speed. So we'll do 40 plus 60, that is 100. So distance when they started moving is 60 kilometers. Relative speed is 100. So time taken to meet is distance when they started moving divided by relative speed. So what will we get? 0.6 hours, right? So 0.6 hours after 10 a.m. because we can cancel the 0 off. So it is 60 by 10, which is 0.6 hours. So 0.6 hours after 10 a.m. they will meet each other. So 0.6 hours means how much? Means we can multiply this by 60. That is 36 minutes. So 36 minutes after 10 a.m. they will meet each other. So 10:36 is the time, a.m. is the time when they meet each other. So if two objects are at a distance of 60 kilometers and if one object is moving at 40 and other object is moving at 60, they will exactly meet at 10:36 a.m. And we can actually find it using the formula time taken to meet each other is equal to distance when the both objects started moving divided by relative speed. So I believe this much is clear for you. Okay, so let's get it moving. So we can actually do a question connected to the same now. What is the question saying? Hari and Manoj left place A and B correspondingly and they started traveling towards each other at a speed of 40 kilometers per hour and 20 kilometers per hour. If both left at 9 p.m., at what time will they meet if the distance between them is 600 kilometers? So we know that time taken to meet each other. So time taken to meet each other is equal to distance when they started moving, distance when they started moving, all divided by relative speed. So time taken by A and B to meet each other is equal to distance when they started moving divided by relative speed. So it is clearly given that they started traveling towards each other when one is from A to B and other person moves from B to A, and distance between A and B is 600 kilometers. So they started from A and B correspondingly at a speed of 40 and 60, and distance between A and B is 600 kilometers. So distance when they started moving is 600 kilometers. And what is the relative speed? One person is moving from A to B at a speed of 40 kilometers per hour. Other person is moving from B to A at a speed of 20 kilometers per hour. So what is the relative speed? These two objects are moving in the opposite direction, right? So relative speed is nothing but the sum of the speeds. So what is the sum of the speeds? That is 40 plus 60, right? Sorry, 40 plus 20. So since they are moving in the opposite direction, relative speed is the sum of the speeds. So time taken to meet each other is equal to distance when they started moving divided by relative speed. So distance when they started moving is 600 kilometers. So because they started left places A and B correspondingly, and distance between A and B is 600 kilometers. So distance when they started moving is 600 kilometers, and relative speed is the sum of the speeds since they are moving in the opposite direction. So distance when they started moving divided by relative speed gives us a time. So it's 600 by 60. That is after 10 hours they will meet each other. So 10 hours after what time? So 10 hours after 9 p.m. because they both left at 9 p.m. right? So 10 hours after 9 p.m. they will meet each other. So what is 10 hours after 9 p.m.? So 12 hours after 9 p.m. is next day 9 a.m. So 10 hours after 9 p.m. means we have to reduce 2 hours from that. So 12 hours after 9 p.m. is 9 a.m. So 10 hours after 9 p.m. means 2 hours before 9 a.m. that is 7 a.m. right? So at 7 a.m. they will meet each other. So 7 a.m. will be the correct answer. Because 10 hours after 9 p.m. means 12 hours after 9 p.m. is 9 a.m. So 10 hours after 9 p.m. means 2 hours before what is it? 9 a.m. That is 7 a.m. will be the correct answer. So I believe this is clear for you. But in certain questions, the problem is they might not start at the same time. So we know that the time taken to meet each other is distance when both started moving, right? So we cannot figure out the distance when only one person is moving. We have to exactly figure out what is the distance when both starts moving. And that is what we have to plug it in here. Now, in certain questions, we will not get an idea at what distance when they both starts moving. So at a certain point of time, only one person might be moving and other person might be starting at a different time. So when both starts moving, what is the distance is what we have to find out, and that is what we have to plug it in on the top. Okay, so let's look at another question connected to the same. Okay, so look at this question. A and B started from the same place and each of them has to travel to a point. A leaves at 9 a.m. and walks at a speed of 4 kilometers per hour. B leaves at 11:30 and rides at a speed of 9 kilometers per hour. When do they meet each other is the question. Okay, so A and B started from the same place and each has to travel to a point. So both are actually starting from the same place, right? So both A and B are starting from the same place and they have to move towards a point. So let's say this is the point P. But we don't know how much far away is the point P. But it is clearly given that A leaves at 9 a.m. and walks at a speed of 4 kilometers per hour. And B leaves at 11:30 a.m. and B moves at a speed of 9 kilometers per hour. So A moves at a speed of 4 kilometers per hour, B moves at a speed of 9 kilometers per hour. A already left at 9 a.m. but B leaves from the same place only at 11:30, right? So who is moving first? A is moving first. So what is that formula? So time taken to meet each other is equal to distance when both objects started moving divided by relative speed. So at 9 a.m. both the objects are not moving because only A left this place at 9 a.m. So from 9 a.m. to 11:30 a.m. only A is moving forward and B starts from the same place only at 11:30, right? That is what this question says. A leaves at 9 a.m. and walks at a speed of 4 while B leaves at 11:30 only from the same place and rides at a speed of 9. So that means from 9 a.m. to 11:30 a.m. only who is moving? A is moving. And what is the speed of A? It is 4 kilometers per hour. And what is the gap from 9 a.m. to 11:30 a.m.? That is nothing but 2.5 hours. So that means A is moving at a speed of 4 kilometers per hour for how many hours? 2.5 hours. I believe that is clear for you. So from 9 to 11:30, that is for 2.5 hours, who is moving? Only A is moving and A speed is 4 kilometers per hour. So if a person moves for 2.5 hours at a speed of 4 kilometers per hour, what will be the distance he moves forward? So we know that distance equals speed into time, right? So when we take the case of A leaves at this place at 9 a.m. and B leaves from the same place only at 11:30. That means from 9:30 11:30, that is for 2.5 hours A is moving forward. So that means for 2.5 hours A is moving forward at a speed of 4 kilometers per hour. So distance travel will be speed into time, which is 4 into 2.5. What is 4 into 2.5? That is 10 kilometers, right? So that means A will be 10 kilometers ahead of B by the time B starts at 11:30. Okay, so I'm just erasing this case, that is A is not at this point now. By 11:30 A will move forward how much distance? 10 kilometers ahead, because 9 to 11:30 is 2.5 hours and A is moving at a speed of 4. So by 11:30 A will be 10 kilometers ahead of B. So A will be 10 kilometers ahead of B by the time B starts from the same place. Now the time is 11:30, right? Now the time is 11:30 a.m. So what is the time taken to meet each other? That is distance when both objects started moving divided by relative speed. So we know that at 11:30 both A and B starts moving. So A already left a place at 9:30 till 11:30 A is only moving. But from the same place, B starts at 11:30. So when both starts moving, the distance between them is 10 kilometers, right? So A will be 10 kilometers ahead of B by 11:30. So when both starts moving at 10:30, distance between them is 10 kilometers. And what is the relative speed? A moves at a speed of 4 kilometers per hour and B moves at a speed of 9 kilometers per hour. So what is the relative speed? They are moving in the same direction, right? So relative speed is a difference of the speeds. So it's nothing but 9 minus 4. So relative speed is nothing but 5. So what is the distance between the two objects when they started moving? That is 10. What is the relative speed? That is 5. So 10 by 5 is basically 2 hours. That means after 2 hours they will meet each other. So 2 hours after 11:30, because it will take 2 hours after this from this point to meet each other, because at this point both starts moving, distance is 10, relative speed is 9 minus 4, because one is moving at 4 and other is moving at 9 in the same direction, because both are moving to the same point. So relative speed is 9 minus 4, which is 5. That means after 2 hours they will meet each other. So 2 hours after 11:30, so we are starting from 11:30. So 2 hours after 11:30 means, what is 2 hours after 11:30? 12:30, 1:30. So time taken to meet each other is, time at which they meet each other is 1:30 p.m. So from 11:30, it will take 2 hours extra. So 2 hours after 11:30 is 1:30 p.m. So 1:30 p.m. will be the correct answer. So I'll just conclude it or summarize this. So the problem in this question is both A and B are not starting from the same, they are both starting from the same point but not at the same time. So A starts at 9 a.m., B starts at 11:30 only. So that means from 9 to 11:30, A moves forward from the same point. So from the same point, B starts at 11:30 only. So from 9 to 11:30 means for 2 hours, who is moving? A is moving. And A moves at a speed of 4 kilometers per hour. That means by 11:30, A will be 10 kilometers ahead of B. So when both starts moving, distance between them is 10. And what is the relative speed? It's the difference of the speeds. It is 9 minus 4. So time taken to meet is distance when they started moving divided by relative speed. So both starts moving at 11:30. At that time, the distance between them is 10. Relative speed is 9 minus 4, that is 5. So distance by relative speed, 2 hours is the time which they take to meet each other. So 2 hours after 11:30 means at 1:30 p.m. they will meet each other. So I believe this is clear for you. So let's move ahead with the next question. Now the next question is a very interesting question. This is a story of a policeman, a thief and a dog. So let's see what the question says. A policeman and a dog are standing together and they spotted a thief at a distance of 80 kilometers. So a policeman and a thief are standing together and they spotted a thief at a distance of 80 kilometers. At the moment policeman spotted the thief, all three of them started running. So a policeman and a dog are standing together and they spotted a thief at a distance of 80 kilometers. So at the moment policeman spotted the thief, all three of them started running. So who all started running? Dog started running, policeman started running and thief also started running. So this is a story of policeman, dog and a thief. So policeman and dog are standing together. They spotted a thief at a distance of 80 kilometers. At the moment policeman spotted the thief, all three started running. Now dog, policeman and thief are running at 40, 30 and 20 kilometers respectively. So who is running at the highest speed? Dog is running at 40, then policeman is running at 30 and thief is running at 20. And next sentence is the most crucial sentence in this question. Dog is running in between the policeman and the thief till the policeman catches the thief. So what does the dog do? He will run in between the policeman and the thief till the policeman catches the thief. So obviously we know that, see, the policeman and dog are standing together. They spotted a thief at a distance of 80. At that moment all three started running. Now whose speed is the highest? The dog is running at the highest speed, right? And speed of dog is 40. That means who will catch the thief first? The dog will catch the thief first before the policeman, because the speed of policeman is only 30. So dog who is running at 40 will catch the thief first. But what is the dog doing? After touching the thief, he is coming back to the policeman. So all three are running. Thief is running, policeman is running, dog is also running. But dog is running at a higher speed. He will touch the thief, he will come back to the policeman. Again he will run towards the thief, he will touch the thief, he will come back to the policeman. So dog is running in between the policeman and the thief till the policeman catches the thief. Now the question is, what is the total distance traveled by the dog? So how much the dog will run in between is the question. Okay, so let's break it down. Okay, let me just draw it up. So we have dog and police standing together. They spotted a thief at a distance of 80 kilometers. So at the moment policeman spotted the thief, all three started running. So dog is running at 40, policeman is running at 30, and thief is running at 20 kilometers per hour respectively. So obviously dog will catch the thief first because dog's speed is higher than the policeman's speed. But what is the dog doing? He will touch the thief, he'll come back to the policeman. Again he will run towards the thief, he'll come back to the policeman. So dog is running in between the thief and the policeman till the policeman catches the thief. So when will the dog started running? Dog started running along with the policeman. When will the dog stop running? Dog will stop running when the policeman catches the thief, right? Okay, let's find the distance distance which the policeman takes to catch the thief. Just ignore the dog for the time being. Let's take the case of policeman and thief. So what is the time taken by the policeman to catch the thief? That is distance between the policeman and the thief is 80. And what is the relative speed? It's 10. So 80 by 10 is nothing but 8 hours, right? So 8 hours is what the policeman takes to catch the thief. Is that clear? So time taken by the policeman to catch the thief is nothing but 8 hours. Is that completely fine? So policeman is running at 30, thief is running at 20. So we know the time taken to meet is distance when they started moving divided by relative speed. So what is the distance between the policeman and the thief when they started running? Policeman spotted the thief at a distance of 80. And what is the relative speed? It is 30 minus 20 because they are moving in the same direction. So 30 minus 20 is 10. So time taken by the policeman to catch the thief is 80 by 10, which is 8 hours. That means after 8 hours, what will happen? The policeman will catch the thief. And what is the dog doing? He is running in between the policeman and the thief till the policeman catches the thief, right? So dog started running along with the policeman and dog is running till the policeman catches the thief. That means dog is also running for 8 hours because the time taken by the policeman to catch the thief is distance when they started moving divided by relative speed, which is 80 by 10, which is 8 hours. That means for the same 8 hours, who is running? Dog is also running. So what is the speed of the dog? Speed of the dog is 40 kilometers per hour, right? So dog is also running for 8 hours at a speed of 40. So time taken by the dog. So what is the question? What is the total distance traveled by the dog, right? So what is the speed of the dog? So we are finding the distance traveled by the dog. That is speed of dog into the time which the dog runs, right? What is the speed of the dog? It is 40. And we know that the dog started along with the policeman and it stops running when the policeman catches the thief. That means dog is also running for 8 hours at a speed of 40. So total distance traveled by the dog will be 40 into 8, which is 320 kilometers. So 320 kilometers will be the correct answer. So I'll just summarize this. So there is a policeman, there is a dog and there is a thief. So who is running at a speed of 40? Dog is running at a speed of 40. Policeman is running at a speed of 30. Thief is running at a speed of 20. So let's find out how much time will the policeman take to catch the thief. So they're moving in the same direction. So speed of policeman is 30. Thief is 20. So relative speed is 10. And the policeman spotted the thief at a distance of 80. So when they started moving, running the distance between them was 80. Relative speed between the policeman and the thief is 10. So distance by relative speed is the time taken by the policeman to catch the thief. So 80 by 10, 8 hours is what the policeman takes to catch the thief. So dog started along with the policeman and dog continues to run till the policeman catches the thief. That means dog is also running for 8 hours and we know the speed of dog is 40. So that means distance traveled by the dog is speed of dog into time for which the dog runs. So distance traveled by the dog is speed of dog is 40. Time for which the dog runs is also 8 hours. Because this dog started with the policeman, it continues to run till the policeman catches the thief. So policeman is taking 8 hours to catch the thief. That means dog is also running for 8 hours at a speed of 40. So distance traveled by the dog will be 320 kilometers. So I believe you got some idea how the time speed distance questions are. And in this session, we were actually focusing more on uh, relative speed. So in we know that when two objects move in the same direction, relative speed is a difference. When two objects move in the opposite direction, relative speed is the sum of the speeds. So these are the things which we discussed today. So I believe you understood all the concepts. Practice more and more questions. We'll meet again in the next video. Thank you so much. Bye bye.